this is predicting the rating of movie using an ML model, and it's predicting the rating or the score based on these parameters that you can see, like title, country, rating, budget, then genre, company name, cast and crew details, runtime in 120 minutes, right, year of when this movie was released, right? So release date and the stars acted in this movie. And based on all these parameters, we are getting the predicted rating of 8 out of 10, while the actual rating of the movie was 7.7 in IMDb out of 10, which is near to the actual rating. So that's how we are able to predict based on this parameter. We are going to build a application which will predict movie ratings based on these parameters. The generative insight with BigQuery SQL and Vertex AI. That's what we are going to follow. So this is the generative insight with BigQuery, SQL, and Vertex. This is our code lab link. We'll follow these steps to perform this lab. Next is GitHub link. So movie score generative AI insights. This is the data set. So the data set for this use case is movie data set derived from movie lens source. This is the source file or path from where we can get this data. Data to ML. Movies dataset stored in BigQuery movie score. In this code lab, we will build a movie success rating prediction and prescription app with BigQuery SQL queries and Vertex AI PaLM API. The model used to perform text generation is text Python and is hosted as a remote function in BigQuery. The list of services uses BigQuery ML, Vertex AI PaLM API, Cloud Shell. What you will build, you will create these a BigQuery dataset to contain the model, a BigQuery ML model that predicts the success score of a movie based on the genre and runtime attributes of the movie, BigQuery model that hosts the Vertex AI PaLM API as a remote function, an external connection to establish the connection between BigQuery and Vertex. Click Next. A browser, which we have already, a Google Cloud project with billing enabled. Now, begin your console on the project sector, select or create a Google Cloud project. Okay. First, let me go to this. Google Cloud Console. I'll agree and continue. Next, we need to have developers credit. We'll apply this developers credit. So just let's redeem that. Accept and continue. And now the credit is applied. That's creating a project. And this is the project ID, project number, and project name. So now this credit is applied. Let's start our hands. So we'll go to Google Console and select or create a project. Now in the Google Cloud Console on the project selector page, select or create a Google Cloud project. Make sure the billing is enabled for your cloud project. Learn how to check if the billing is enabled. Make sure all the necessary API like BigQuery, Vertex API, BigQuery connections are enabled. You'll use Cloud Shell, a command line environment running in cloud that comes preloaded with BigQuery. So refer documentation for Google Cloud commands and usage. From the Cloud Console, click Activate Cloud Shell on the right corner. So I'll do that. Let's click Activate Cloud Console. Here we can see Cloud Shell is free for all users. Just click Continue, and now it's starting to connect to the Cloud Shell. We can see the statuses of the cloud platform status, all services normal, and now we are connected to our Cloud Shell using this account, and this is the project number or name, project ID basically. If your project is not set, use the following command to set it. Google Cloud config set project, new project ID. Navigate to BigQuery console directly. Let me copy this first, and then regal seater 42,607. Google Cloud Shell needs permission to use your credentials for command line authorize, and now updated property for project. Okay. Now navigate to BigQuery console directly by entering the following URL in the browser. BigQuery Cloud Console. We are in the BigQuery Cloud Console, and this is our project. This is external connections. Preparing data. So to prepare data, what we have to do in this use case, we'll use the movie data set derived from movie lens source. Create a data set. So first step would be in preparing data is to create data set. A BigQuery data set is a collection of tables. All tables in the data set are stored in the same data location. You can also attach custom access control to limit access to data sets and tables. In Cloud Shell, use the bulk query mk command to create a dataset called movie insights. So we have to copy this, paste it here, and press enter. So dataset movie insights successfully created. How we will know? We'll just refresh this, and here we can see movie insights dataset. Let's open the console here. I'll close this another tab. So now this data set is created. We can click and we can see these details. Movie insight created, data location, default rounding mode, case insensitive, false, and all these things. Next, clone the source file to Cloud Shell machine. So we need to clone the source file to Cloud Shell machine, and to do that, copy this and paste it in Cloud Shell, and I'll clone this repository. Okay, so everything is cloned now. Let me do a listing of directory. You can see movies for Gen AI or Generative AI Insights folder created. I'll change directory to this movies for Generative AI Insights, and again list the directory. You can see we have BigQuery Cloud Shell command, license, movie dataset CSV file, and README file. So all these four files. Next, once this step I have already covered, so change directory to this folder. Then we will load the CSV file that we have inside this directory using this command. Copy this. Let's paste it here and press enter. So it's formatting, or it's trying to load the CSV file, which has one leading rows And these are the column names and the data type for each column mentioned, decided. This is the file source. Now this upload is complete. Once we refresh contents, you will be able to see movie insights. Under that dataset, we have movie score. And these are ID, names, rating, genre, year, released, date, score, data, then director, writer, star. Okay. These are the details. Preview. This will give us preview of the data that we loaded from CSV. Okay. So we have 7,668 records within this CSV file. Let's You can query a sample to check if the table, movie score, and data are created in dataset. We can use this BigQuery to also check, run in the command. This is a command prompt script and not the BigQuery script. So sorry for that. Got confused. And here, let's enter this, and we can see it's loaded with the name, rating, genre, time. So yeah, we have the data. Through this refresh, also we saw movie score data here. Let's move to the next step. Data to ML. So let's create a classification model to predict the success score of movie based on genre and runtime. We will use the create model statement with the option logistic regression to create and train a logistic regression model. Okay. Run the below query in BigQuery console SQL workspace query editor section. Okay. So create or replace model with this would be the model name movie insights.model rating by runtime genre, and the option is regression, logistic regression we are applying. Auto classifier weights true, data split method no split, model registry Vertex AI, and Vertex AI model version aliases, logistic regression or experimental. Input label columns is 4, and then as select name, genre, runtime score from movie score dataset where data category is training. So if you see here, we have data category for training and test. Okay, so some of the data or records will be used for training, some of the records will be used for testing the model. So I'll copy this here, and now we need to go here and paste it here and then run it. Here we see model registry failed, Vertex AI API has not been used in project this before, or it's disable. Enable it by visiting this, then retry. If you enable this API recently, wait for a minute for action to propagate the systems and retry. So let's open this. We will enable Vertex AI API for our project. This will help train high quality custom machine learning models with minimal machine learning expertise. Now this Vertex AI API is enabled. We can see the status here. Now go back and execute this again. And now we can see successfully created model name. This, if we click on this, we can go to the model. We can see it also from here. Models. Under that, we have model rating. This is created just now. It's logistic regression. Okay. And this is the model ID. The project name, then movie insights. Under that, we have model rating by runtime genre. Okay. And these are some training options of parameters. Next, query details. The create model statement trains a model using the training data in the select statement. The option clause specifies the model type and training options. Here, the logistic regression option specifies a logistic regression model type. It is not necessary to specify a binary logistic regression model versus a multi-class logistic regression model. BigQuery ML can determine which to train based on the number of unique values in the label columns. Data split method is no split, forces BigQuery ML to train on the data per the query condition, which is data category equal to training. Also, note that it's better to use the auto split in this option to allow the framework or service in this case to randomize the partition of training and test splits. Okay, so this will randomize training and test split so that our model is not biased. The input labels columns option specifies which column in the select statement to use as a label column. Here the label column says score, so the model will learn which of the 10 values of score is most likely based on the other values present in the each row. The auto class weight equal to true option balances the class labels in training data. By default, the training data is unweighted. If the labels in the training data are imbalanced, the model may learn to predict the most popular class of labels more easily. The select statement queries the table will loaded with the CSV data. The where clause filters the row in the input table so that the training data set is selected in this step. The following constructs are optional, so BigQuery ML can explicitly register it to Vertex AI model history. You can read about this more in the blog link here. And the model history is Vertex AI and model version aliases is logistic regression and experimental. Once created, the below appears in the schema section of the BigQuery workspace. These are the labels of the data set. And after creating your model, evaluate the performance of the model using ml.evaluate function. The ml evaluate function evaluates the predicted values against actual data. You can also view the evaluation metrics of your model from the model page. So here, if you go to training, you can see these graphs. Then in the evaluation page, we can see aggregate matrices. So these are threshold, precision, recall, accuracy, F1 score, log loss, ROC, AUC. These parameters we can see. Area under the receiver operating characteristics value. That's the full form. The measure for model performance between 0 as perfect and the 1. The greater the log loss, the greater the predicted probability diverges from the actual label. Okay. You can click on confusion matrix item counts, and here you can see it's giving a confusion matrix. And this is the percentage wise matrix. If you want to see the percentage of the count, actual count, you can see this one. Next, key matrices at a glance, precision, which what proportion of positive identification was actually correct. Precision true positive divided by true positive and sum of true positive and false positive. Recon, what production of actual positive was identified correctly. Recall equal to true positive divided by sum of true positive plus false negative. Accuracy, a matrix of evaluating classification model. It is the fraction of predictions our model actually got right. And then accuracy equals to the number of correct prediction divided by total number of predictions. Now predicting movie score using the model. Prediction time. The following query predicts the score of each movie in dataset that is categorized as test data. So we'll use the test data to predict the movie score. Now run the below query in BigQuery console, SQL workspace query editor section, and let's copy this and create a new query, paste it here, just run it. And now we can see the query result or prediction. So predicted score is 7. Predicted score, probability labels, all these details are there. Now this is the ID, legend of deification. This is the movie name, and we have got predicted score as 7. This has animation genre released in 2020. Actual score was 7. Director, writer, star, country, budget of the movie, and all those things. Runtime 110 minutes, and data category was touch. So for this, randomly we pick this, okay, and we predicted its score. Now the results looks like this. The model results show the predicted score of the movie on a scale of 1 to 10 classification. You must be wondering why there are several prediction rows against each movie. That's because the model has returned the possible predicted levels and the probability of occurrence of each one in decreasing order. So we have 7 here. We have 7 here as well. Wonder Woman, Tulsa, My People, My Country. So there are some more movies with their scores. So we have around 36 such train data. Okay. Now that is because the model has written the possible predicted labels and the probability of occurrence of each one in the decreasing order. Now analyze predicted result and the model. You can do two great analysis steps with the prediction to understand the result. To understand why your model is generating these prediction results, you can use the ML explain predict function to know which features are the most important to determine the income bracket in genre. You can use the ML global explain function. You can read about these steps in details in documentation. We'll move to data to generative AI. Now let's deliver insight on the movie's dataset by asking LLM or large language model the summary of factors that influence the movie score to be greater than 5. The generative AI using Vertex AI text Python or latest model using only SQL queries. Now we are going to use large language model to get the insights on the movie dataset prediction, and wherever we have a movie score of more than 5, we are going to ask our large language model explain why was the reason for such a score. Okay, and for that we'll be using SQL queries. The table we created movie score will be the input for this step as well. External connection will be created to establish the access between BigQuery ML and Vertex services, and BigQuery generate text construct will be used to invoke the PaLM API remotely from Vertex. So let's click next. Create an external connection. Enable BigQuery connection API if not already done, and note down the service account ID from the connection configuration details. Okay. Click the add button on the BigQuery Explorer pane in the left of the BigQuery console and click connection to external data sources in the popular sources list. So we have to go here. We have to click on add connections to external data sources. We have to click, and we have to click enable API. Select connection type as big lake and remote functions. Okay. We have to select big lake and remote functions. Okay. There are other connection types as well, like Cloud SQL, PostgreSQL, Big Lake on AWS, Big Lake on Azure, Cloud Spanner, Apache Spark. We select Big Lake and remote functions. We have to give the connection ID as this will be the connection ID. We select region, specify a region to co-locate your dataset with other cloud services. So US Central, 1 Iowa. So this is US Central Iowa. Fine. Once the connection is created, take a note of the service account generated from the connection configuration details. Okay, so let's create connection. Now go to the connection. This is the service account ID. I'll copy this. In this step, we will grant permission to the service account to access the Vertex AI service. Open IAM and add the service account you copied after creating the external connection as a principal and select the Vertex AI user role. So we have to open IAM and add the service account. In the search box, you search IAM and here you can see, let's click on this. So in the IAM, I'll click grant access, new principal. So I'll paste this here. I selected this and then assign a role, Vertex AI user. Vertex AI user. So I search this Vertex AI user. Now this is role is set, service principal account is set. I'll save this. Click next. Create a remote ML model. So now creating external connection is done. Now we are moving on to creating a remote machine learning model. To create a remote machine learning model that represents a hosted Vertex AI large language model, we have to do that. To run this command, the BigQuery. So I'll open a new tab, paste it here, and here what we see. Create or replace model with connection, which is this remote connection to a remote location, US Central 1, BigQuery LLM connection. So we are using this connection. Okay. And then remote service type is Cloud AI Large Language Model version 1. Okay. So now let's run this. And our model is created. This is a remote ML model. Let's refresh this. And here we can see LLM model, large language model. And the remote endpoint is this one. Projects, project ID, location, which is US Central 1, publisher is Google, model, text bison, iteration one time. It creates a model named this and the dataset. In the dataset move inside, which leverages the Cloud AI Large Language Model version 1 API of the Vertex AI as a remote function. This will take several seconds to complete. Click next. Now once our remote ML model is created, we'll generate text using ML model. Okay. Once the model is created, use the model to generate, summarize, or categorize text. So let's copy this and again paste it here. Now let's see the explanation. ML generate text result is the response from the text generation model in JSON format that contains both content and safety attributes. So first let's run it. Now we can see this is the generated text, safety attributes, ML generated status and prompt. I'll go to JSON data. So here we can see this is the generated text output. We have safety attributes like false, categories, scores, etc. ML generated text status is blank, and this is the prompt we have given. From the following text about movies, what do you think are the factors influencing a movie score to be bigger than 5? A movie named American Gigolo of the country United States. So all these write-ups are written. So this much text were given for prompt. Okay. So this is our prompt. So this concat is nothing but prompt. Okay. And the the data from the movie dataset is extracted and appended with this question to make a larger prompt. Okay, so let's see the explanation now. So ML generated text result, which is this JSON result, is the response from text generation model in JSON format that contains both content and the safety attributes. Number A, content represents the generated text result. Number B, safety attributes represent a built-in content filter with an adjustable threshold that is enabled in the Vertex AI PaLM API to avoid any unintended or unforeseen responses from the large language model. The response is blocked if it violates the safety threshold. Then ML generate text is the construct you use in BigQuery to access the Vertex AI LLM to perform text generation tasks. Now, concat appends the prompt statements and the database records. Movie insight is the dataset name and the movie score is the name of the table that has the data we will use in the prompt design. Temperature is a prompt parameter to control the randomness of the response. Lesser the better in terms of relevance. Max output token is the number of words you want in response. The query response looks like this, or in JSON format it looks like this. Okay, or in the result tabular format it looks like this. So you can always expand this as well. Now let's move to the step 10 where we flatten the query results. Currently it's generated as a JSON response. So let's flatten the results so that we don't have to decode the JSON explicitly in the query. So we'll copy this and we'll paste it here. This will flatten the results and show us as a textual format in the sentence mode, or basically we'll see the sentences. So here we are putting flatten JSON out. Okay. And this is our result. So now the generated text result is in a flattened format or not in the form of JSON. So if you see here earlier in JSON, even this response was coming as a JSON, but here we have flattened this result. Now flatten JSON output represents a boolean which, if set true, returns a flat understandable text extracted from the JSON as form. The query response looks like this. Let's see the ML generated text result. And here we can see, based on the given information, the following factor seems to influence a movie score to be greater than 5. Genre. All the movies with a success score greater than 5 belongs to the crime genre. Censor rating. All the movies with a success score greater than 5 have a censor rating of R. Okay. So these are the insights we are getting from our model, generative AI model. Previously, what we saw here in the result, it was having these extra new lines and other things, which is now flattened. Next, cleanup. To avoid incurring charges to your Google Cloud account for resources used in this post, you can delete the Vertex AI endpoint that you created as part of ML step by navigating to Vertex AI endpoint page. Click next. So we have successfully created a BigQuery ML model, machine learning model, and performed large language model based analytics using a Vertex AI API on movie dataset using only SQL queries. So that's all for now in this session. You can bookmark or see this website where all the write-ups are given. You can also go to this page, codelabs.developers.google.com/generative insights SQL only. So this is the code lab page. generative insights with BigQuery SQL and Vertex AI. That's the hands-on we did. Build a movie success rating, production and prescription app with a BigQuery SQL and Vertex.